Hello again, math friends. Today's episode we're going to look at solving systems of equations. A system of equations is a set of two or more equations sharing variables. The purpose for solving a system of equations is to find the point of intersection, or the point that satisfies both equations. So you're looking at where that point is where the two or more lines cross. There are three ways to solve a system of equations. The first is by graphing. We graph the lines, check to see where they intersect. The next method is substitution, where we take one expression and substitute it into the other expression. And the third way is called elimination, where we take two equations or three equations, add them together so that one of the terms adds out of both of the equations. So let's see what we're talking about here. For this first one, we have 3x plus 4y equals 8. And if I'm going to solve this by graphing, I need to be able to graph that line. So I'm going to take the 3x plus 4y equals 8. This is in standard form. Standard form is ax plus by equals c, where the a term, the x coefficient, is positive. I need this in slope-intercept form because slope-intercept form is easier for graphing. Y equals mx plus b, because b is my y-intercept, m, the coefficient of x, is my slope. So I'm going to take this equation and subtract 3x from both sides. The 3x's add out. I get 4y equals, I'm going to go ahead and switch the order. We want the x term first. Then divide by 4, divide by 4. The 4's divide out. We get y equals, I can go ahead and split these into two fractions. Plus 8 over 4. Y is equal to negative 3/4 x plus 2. So to graph this, we graph the point. The y-intercept is the point 0, 2. You put 0 in for x. And so our y-intercept is this point right here. Our slope is negative 3/4. Remember, slope is rise over run. So in this case, our rise is going to be down 3 units, and our run is going to be forward 4 units. So from our intercept point, we go down 3 units because of it being a negative 3. 1, 2, 3, and we go forward 1, 2, 3, 4 at that spot right there. We could continue. We could go down 1, 2, 3, forward 1, 2, 3, 4. We can do that as often as we want, but this gives us a line that goes through like that. Of course, this extends some more this way. Then we take our other line, the 3x minus 8y equals 56. And I'm going to get this in slope-intercept form, so I'm going to subtract 3x. And so the 3x's add out. I get negative 8y. The 3x's add out. I get negative 8y. I'm going to reverse the order here because we want the x term to be first. Then we divide by negative 8. Divide by negative 8. We get y equals a positive 3/8 x minus 7. 56 over negative 8 is negative 7. So our y-intercept is the point 0, negative 7. 1, 2, 3, 4, 5, 6, 7. So there's our y-intercept. Our slope is 3/8, so we're going to rise or go up 3 units. Our run is going to be forward 8 units. So we would go up 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. So I can see right there that my line goes through those 2 points. There is the point of intersection, and that point is the point 8, -4. So the solution to this system of equations is the point 8, -4. We could check that by putting the 8 back in for the x and the -4 back in for the y, evaluating this side and making sure that we get 8 on this side to match this side. The same thing with this point, put 8 in for x, -4 in for y, evaluate this side, make sure we end up getting a positive 56 on this side, the 2 sides being equal. That means that that point satisfies that equation. Okay, let's take a look at this next one. We're told to solve this system by substitution. Anytime you're solving by substitution, you want to look for a place where you can take and solve for one of the variables very easily. Here, when I look at this system, I see that I have an x with a coefficient of 1, so it would be very easy to take this equation and solve it for x to get everything else on the other side. I'm going to label my steps, and I always use letters so that my numbers don't get confused with my letters. And so I'm going to start with this equation, and I'm going to solve it for x. So I need to add 2y, and then the y's add out. I'm left with x, and I have -9 plus 2y. Now I'm going to take this expression that is equal to x and take it and put it right there. So my step B is to take 2x plus 3y equals 17. And I'm going to take this expression and plug it back in for x. I can't take this and go back to the same equation I worked with, because then everything's going to add out and I won't be getting anywhere. So I have to use the other equation. So this goes in right here, and I get 2 times -9 plus 2y plus 3y equals 17. Distributive property, 2 times -9 is -18. 2 times 2y is 4y plus 3y equals 17. Combine my like terms, I get -18 plus 7y equals 17. We're solving for y, so I need to add 18 and add 18. Here the 18s add out, I get 7y. 17 and 18 is 35. Divide by 7, divide by 7. Y equals 5. This means that the y coordinate of the solution is 5. In order to find the x, we go back to either equation. It does not matter which one. Since this one has smaller numbers, I'm going to use it. X minus 2y equals -9. And you notice I always start off with what I'm going to be working with. So I'm working with that equation. Now I'm going to take the 5 and plug it right in here for y. I get x minus 2 times 5 equals -9. X minus 10 equals -9. Then we need to add 10 and add 10. The 10s add out. We get x equals -9 plus 10 is +1. So the solution to this system is the point 1, 5. And I can check this by taking the 1 and putting it in for the x, the 5 and putting it in for y. evaluating this side and make sure that it comes out to be 17 like on the other side. Put 1 in for x, 5 in for y, evaluate this and make sure that on this side I get -9 that matches that side. Then I know that that is the correct solution to the system. All right, in this problem it says that we also want to use substitution. Again, it does not matter what I work with. I see that I have two variables that have coefficients of 1, so I'm going to start with that equation. And I think I'll solve for x again, because that way my y will be positive on the other side, because I'm going to add y and add y. The y's add out. X equals 6 plus y. Now take this and put it in for x in the second equation. I have to go to the second equation. Put 6 plus y in for x. I get 2 times 6 plus y minus 5y equals 30. Distributive property, 2 times 6 is 12. 2 times y is 2y minus 5y equals 30. Then combine like terms, 12 minus 3y, positive 2 and negative 5 is negative 3, equals 30. We need to subtract 12. I'm sorry. We need to subtract 12 and subtract 12 from this side. The 12s add out. We have negative 3y. 30 minus 12 is positive 18. Divide by negative 3. Divide by negative 3. The 3's divide out. 18 divided by negative 3 is negative 6. So the y coordinate of the solution is negative 6. To find the x coordinate, we go back to either equation. This one's got smaller numbers, so my step C is going to be to take x minus y equals 6. Again, notice how I write down what I'm starting with first. Plug the negative 6 in, I get negative 6. I get x minus negative 6 equals 6. This is x minus a negative is x plus 6 equals 6. If we subtract 6 and subtract 6, these add out. So do these. We get x equals 0. So the solution to that system is the point 0, negative 6. All right, this time we're being told to solve by elimination. In elimination, you want terms to add out. And I can see right away that I have a positive 3y and a negative 3y. Those are going to add out if I add the two equations together. So I'm going to take x plus 3y equals 8. And I'm going to take 2x minus 3y equals negative 2. And I'm going to add these two equations together. X plus 2x is 3x. Positive 3y and negative 3y add out. 8 minus 2 is positive 6. Divide by 3. X is 2. So the x coordinate of the point of intersection for these two lines is 2. And now we take that and plug it back into one of those. I'm going to use the x plus 3y equals 8. Put 2 in for x. Subtract 2. Subtract 2. These add out. 3y equals 8 minus 2 is 6. Divide by 3. Divide by 3. Y is 2. So the point of intersection for those two lines is the point 2, 2. All right, let's take a look at this one. Again, we're being told to solve by elimination. But here it's not as easy to see that I have two terms that'll add out. But I could easily fix this term. If that were plus 2y, then those would add out. So my step A is going to be to take 2x minus y equals 2, and I'm going to multiply both sides of that equation by negative 2. Because negative 2 times negative 2 times negative y is going to be a positive 2y. So distributed property, negative 2 times 2x is negative 4x. Negative 2 times negative y is positive 2y. And if we do that on this side, we have to do it on this side. I get negative 4. Step B is now going to be to take this new equation and add the other equation to it. 3x minus 2y equals 5. Negative 4x and a positive 3x is a negative 1x. These add out. Negative 4 and positive 5 is a positive 1. Divide by negative 1. These divide out. We get x equals negative 1. So the x coordinate of the solution is negative 1. Now we need to take that negative 1 and plug it back into one of these. I'm going to choose 2x minus y equals 2. You may say, why did I choose that one? It doesn't matter, but I see that they're smaller numbers. I like to work with smaller numbers whenever possible. 2 times negative 1 minus y equals 2. So we took the negative 1 and plugged it in. This is negative 2 minus y equals 2. So I need to add 2. Add 2. These add out. Negative y equals 4. Divide by negative 1. The negatives divide out. Y equals negative 4. So there's the point of intersection for these two lines. Okay, again, we're told to solve by elimination. When I look at these, if this were a negative 5x, those would add out. So I think that's what I'm going to do. I'm going to change the first equation, and I'm going to take both sides and multiply by negative 5. Negative 5 times x is negative 5x, and see that negative 5x will add to 0 with that positive 5x. Negative 5 times positive 2y is negative 10y, and negative 1 times negative 5, positive 5. Now I'm going to take this new equation. Notice I'm writing it down, and then taking the second equation that we did not change, and I'm going to add these two equations together. The negative 5x and positive 5x add out. Negative 10y and 3y is negative 7y. 5 and 16 is 21. Divide by negative 7. We get y equals negative 3. So the y coordinate of that solution is negative 3. Now we need to take the negative 3 and plug it back in. I'm going to take the x plus 2y equals negative 1. Put the negative 3 in for y. This gives me x minus 6 equals negative 1. The 2 times negative 3. Then I need to add 6. Add 6. The 6's add out. Negative 1 and positive 6 is positive 5. So the x coordinate is 5. Again, if we wanted to check and make sure that was right, put the 5 in for x, negative 3 in for y, evaluate this side and make sure that when we get down here to the bottom, we get negative 1 because that's what the other side is. then put 5 in for x, negative 3 in for y. Evaluate this. When we get down to the bottom, we better get 16 because that's what the other side is. And so that means that that point satisfies that equation if both sides of the equal sign end up being the same. Finally, let's take a look at this one. Again, they want us to use elimination, and I choose, I can see in this with the elimination, it would be difficult to make the y's add out, but the x's would add out if this was a negative 4x. So I'm going to take 2x minus 5y equals 8. I'm going to take this whole side and this whole side and multiply it by negative 2. Because negative 2 times 2x is negative 4x. Distributive property, it's going to add out with that 4x. Negative 2 times negative 5 is positive 10y. And 8 times 2 is negative 16. So now my step B is to take negative 4x plus 10y equals negative 16 and take the other equation that I did not change and we're going to add those up. The x terms add out, we get 7y, and in this case our constants add out, and so if we divide by 7, y is 0. It's nice when they come out nice and easy like that, isn't it? Alright, now we're going to take the 0 and plug it back in. Doesn't matter which one I start with. This one seems to have smaller numbers. So 2x minus 5 times 0 equals 8. So 2x minus 0 equals 8. That's 2x equals 8. Divide by 2, x is 4. So the solution to this system is the point 4, 0. Again, remember, if we were to graph these two lines, they would cross at this point 4, 0. That's the whole reason we solve systems of equations. All right, that wraps up this episode. Check out all of our other videos on our YouTube channel at MathMan1962. Also check out all of our free interactive math activities at our EdTech website, edtech.dnjdesigns.org. Thanks again for watching, and we'll see you on the next episode. So long.
If you liked this video, please click on the thumbs up. If you want to see more videos like this, please click on the subscribe button. And if you want to be notified when new videos are posted, please click the bell.